I'm sorry, there seems to be some technical error. We'll begin with the further proceedings of our event. Um,
Seven, 8, 5, 4.
Good afternoon, ladies and gentlemen. Welcome to the Chandrayaan 3 screening event, organized by a dedicated, resilient, and a stellar team which believes and aims to foster awareness on the untold topics by most students. We strongly believe that this event aligns perfectly with our university's mission to promote educational excellence and create an environment conducive to intellectual growth. We are none other than the Data Science Club of HSNC University. We're thrilled to have you all here today to witness this extraordinary feat of scientific achievement. Tonight, we celebrate the indomitable spirit and discovery. Before we begin, I'd like to extend a warm welcome to our esteemed guest, Vice Chancellor of HSNC University, Dr. Hemlata Bagla ma'am, our Honorable Provost HSNC University, Dr. Niranjan Hiranandani sir, who has joined us online, Registrar HSNC University and Principal of BTTC, Bombay Teachers Training College, Dr. Bhagwan Balani sir, Deans of our institution, Principal of HR College, Dr. Pooja Ramchandani ma'am, Vice Principal KC College, Mr. Samarjit Padi sir, Dr. Shalini Sinha ma'am, Dilip Ram Rakhyani sir, Vice Principal of HR College, Jasbir ma'am, Rani Tyagi ma'am, our academic head, Department of Data Science and Business Analytics, Professor Shaileja Rane ma'am, Director Student Development Cell, Dr. Satish Kolte sir, students, and the brilliant minds that have made this event possible. It is indeed an honor to have each one of you here today. Light is a symbol of brightness and prosperity. It represents the dispelling of darkness and the triumph of light over ignorance. To make this event a blessed one, invoke Goddess Saraswati by kindling the lamp of knowledge and wisdom for seeking the choicest blessings. I'd like to invite all our esteemed guests to seek blessings.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रान्विता या वीणा वरदण्डमण्डितकरा या श्वेत पद्मासन या शंकर सरस्वती भगवती निशेषजाड्या
I would kindly request all our guests to stay back on stage for felicitation. I would like to call upon our academic head, Professor Shaileja Rane ma'am, to felicitate Bagla ma'am. Yes. I would like Dr. Balani to come to the stage for the felicitation. I'd request Sikandar Yadav sir to felicitate Dr. Balani Yadav. I'd like to call upon Anjali ma'am to felicitate Mr. Samarjit Padi sir. I'd like to call upon our president to felicitate Dr. Satish Kolte sir. I would kindly request to fasten our seatbelts and get ready for today's event. I'd humbly request our beloved Vice Chancellor, Dr. Hemlata Bagla ma'am, to stay back on stage. And I'd request our hospitality team to escort our esteemed guests to their respective seats in the auditorium. Today, we are honored to have a distinguished keynote speaker with us, someone who has made significant contributions to the field of science and academia. She embodies the essence of our drive of motivation, inspiring us to reach greater heights and pushing the boundaries of our potential. And believe me, when I say that, I actually mean it. Because if it wasn't her drive and encouragement that backed us, we wouldn't have been here today. When we define power, we're simply describing her, for she is the driving force and inspiration to everyone within our university community. And I'd like to take a moment to offer my gratitude to her for making us believe in ourselves and encouraging us to aspire big. And certainly the learnings have been learned for life. Thank you, and a big shout out for all that you've contributed to this event and your belief in us. We are and will forever be indebted. Although I believe that she needs no introduction, but yet every time I read about her accomplishments, it gives me immense pride to be associated with her. She has been instrumental in promoting research and innovation within our university. With a remarkable background in nuclear and radiochemistry and biomedical domains, she has published more than 170 research papers in national and international journals of repute, including 9 publications in NASA's astrophysical database, and has presented papers in national and international conferences. She has also been the chief scientific investigator of International Atomic Energy Agency and has served as a member of team of top 15 scientists on a coordinated research project. She truly brings a wealth of insight and experience to this event. We're truly privileged to have the opportunity to listen to her insights today. Please join me in giving a warm welcome to the epitome of excellence, our Vice Chancellor, Dr. Hemlata Bagla ma'am, the living embodiment of our collective aspirations. I now request ma'am to take over the podium to address our audience and make her valuable speech and this event a memorable one for all of us.
Thank you, Rohan. Thank you, Rohan, for that elaborated biodata. Reminds me that some work I've done. Thank you. He said, fasten your seat belts. Are you ready? Ready for the launch? All right. First of all, I extend thanks to all of you for sparing your time for this wonderful event. I would say national celebration. If you talk of Chandrayaan 3, it's not less than a historic event. And imagine we all are here to witness that beautiful moment and beautiful historic day. And we will remember for lifetime that we were here in this auditorium and we were part of witnessing that huge leap on the moon by our wonderful and beautiful country who is forging ahead. Welcome all of you on board. I also extend a warm welcome to all the distinguished members who are online, especially Honorable Provost, Dr. Niranjan Hirandani, Mrs. Maya Shahani, Dr. Kishuman Sakhani, and other members of the board who have joined online, and all the students who are there with us today. Can I have the presentation, please? humankind's odyssey into the final frontier space. Yes, the journey began 6 decades, more than 6 decades ago, 4th October 1957. That day, USSR and Soviet Union launched Sputnik, and you are aware of that. Maybe please read it. And Sputnik while getting into the Earth's atmosphere, got burnt within 3 months. But that was the beginning for humankind. And that's where we began our journey into the space. If we talk about Indian space program, and we started in 60s with scientific objectives of exploring Earth's atmosphere, ionosphere, studying astrophysical objects using rockets. And that time, the legends, the scientists who were behind the scene and envisioning a new India to start space program. And here is the man, Mr. Vikram Sarabhai, known as the father of the Indian space program, who played very important role, a pivotal role in establishing India's space research capabilities. And he's the one who laid foundation what INCOSPAR was, and he converted into and renamed into ISRO, that is Indian Space Research Organization. He was also instrumental in establishing Tumba Equatorial Rocket Launching Station, which was the first one, and the story, now you will know how we have moved forward. The other scientist, we all know, honorable former president of, okay, we have the picture, no problem, we have Satish Dhawanji. He was the chairman ISRO from 1972 to 1984. And Satish Dhawanji was instrumental in shaping India's space program. He played crucial role in development of launch vehicles. You must have heard about 2 launch vehicles. One is Polar Satellite Launch Vehicle and Augmented Satellite Launch Vehicle. And apart from that, even now GSLV, he was the man who played immense role or crucial role in the development of these launch vehicles. We all know the missile man of India, Dr. Abdul Kalam ji, and he made significant contribution to space research and also missile technology. He served as the scientific advisor, chief scientific advisor to the Prime Minister, and later he became our 11th president of India. He played his very significant role in India's space and missile programs, and including the Integrated Guided Missile Development Program. You must be knowing Agni and even Rohini satellites was launched by him. When we talk about other members, I have not put it out here, but we will not forget the contribution of Dr. K. Radhakrishnan, who also served as ISRO chairman from 2009 to 2014. And during his tenure, he oversaw the successful MOM, that is Mars Orbiter mission, making India the first country to reach Mars on its maiden attempt. And let me tell you, the Mars is still from 2013, MOM is orbiting, and that brought us on the global map, and we are the only country having successful Mars mission. Let me also talk about and pay tribute to Moon Man of India, Millaswamy Annadurai, and KC College teachers and professors would know. We had felicitated him during the Diamond Jubilee, and he was himself here, and he was the project director of India's Chandrayaan 1, Chandrayaan 2 missions too. And he played crucial role in successful launch and execution of these missions, advancing India's lunar exploration efforts. The other 2 people, I think there are many more, but Ritu Karivdal also, I would say the lady who is Rocket Woman of India, who played very important role, and accomplished scientist at ISRO and mission director of MOM, that is Mars Orbiter mission. So India's program, as I mentioned, started early 60s, and the first venture in the space in 1975 with the launch of Aryabhatta satellite, but not in the Indian soil. It was from the Soviet Union, and I wouldn't say Soviet launcher, but was launched at Soviet Union. And Aryabhatta 75 was the first journey which we took. Moving on, when Apollo story happened, and I want you all to study those, all of you must venture into the moon mission of other countries. There were two nations. There's a statement, two nations, one race. USSR and USA kept competing each other, and every year every couple of years there were satellites being launched and spacecrafts being launched on the moon, and there have been many moon missions, more than 100, and two nations kept competing, and we came in the picture in 2008. But before that, when the Apollo brought lunar samples, the scientists in India got encouraged while working on that. Luna and Apollo, they got the samples, and when scientists worked, Astronomical and Society of India, and even Indian National Academy Sciences in Lucknow, spearheaded by Kasturi Ranganji, who is ISRO chairman, former ISRO chairman, and they thought now is the time India must get into lunar orbit, and that's where the idea of Mission Moon started. So Tata Institute of Fundamental Research, TIFR, was the place where lunar samples came, and I also got to see later the work done on the lunar samples. Next slide, please. When you talk about space story of India, it's not that we can label one person, single individual. It's a collective effort of all the distinguished scientists, passionate scientists, and they were from Indian Academy of Sciences, as I mentioned, and also Astronautical Society of India, when they met in Lucknow and then met at Hyderabad, and Mission Moon conceptualized. The question should be, why Mission Moon? Not this, it can be corrected. The effort of the first year, second year data science students, I wouldn't correct here. Thank you so much for making this beautiful presentation. And what was the reason that we wanted to venture in this area? Just because other countries were launching their spacecrafts? No, it's because India also wanted to make the space its own space and access space through its own indigenous systems and technology. And also, please, previous slide. The lack of information about the moon, its inner core, the magnetic water, and what is the atmosphere looks like, Earth's atmosphere, the solar system, everything could be gauged from studying or with the Mission Moon. Next slide, please. So ISRO is the one which has brought this dream of India in the front line. And today, if we are proud that, if we say that proudly, the Chandrayaan 3 is being launched, is, I think ISRO needs a big round of applause. All the scientists at ISRO today who have worked years and years, thousands of hours, and they have worked to bring these missions into action. So this is what, and it is not about only moon, it's about Mars, and many more missions are planned, and we only send best wishes to all the scientists today and want to tell them that we will stand by whatever happens, but effort will always be fruitful, and it is only a science, is only an experiment. An experiment has different observations and different results. We shall stand by all the scientists today. We mentioned about all the scientists talking about two launching vehicles, and one is PSLV, is Polar Satellite Launching Vehicle, and other is GSLV, is Geosynchronous Launching Vehicle, Mark 1, Mark 2, and Mark 3, based on their capacity, the angular velocity, and these two launching vehicles, if you look at the characteristic models, they are two launching vehicles, and even Chandrayaan 3 also. I shall come back on this point quickly. Please do let me time. We should not miss out on the launching time, because 2:20 we should stop. So these both satellites have brought IRS, that is PSLV has been able to you are carrying IRS, means Indian remote sensing satellite, and it can carry 1 to 1.5 ton class of the satellite in polar sun synchronous orbit. Polar means Earth's polar orbits. So it is easier to be launched there with this kind of weight. And it is used for natural or resource survey applications, or Earth's resource survey applications, and its capability of placing a load of 150 kg, I'm talking of the launching vehicle, in a 1,000 kilometer orbit, and 110 kg around Venus, around the Venus orbit, not respectively. It's all for the INSAT. Coming to Indian National Satellite System, which is another satellite, and you know that if you're able to communicate today, and today if a lot of funds have gone into ISRO, but imagine the double we are making a use of it. If you would have hired international satellite systems, we would have been paying more. So whatever investment has gone into ISRO, we have benefited double or triple, because we have our satellite systems, and there's INSAT, and it is a geosynchronous orbit, and geosynchronous is nothing but is synchronizing in Earth's angular velocity, either equatorial or in the angular orbit, and it is actually used for communication, various other education, health, weather forecasting, everything. INSAT is actually the, I mean, there are variety, there are the thousands of such satellites which are in space. Next, please. So Chandrayaan 1 was, as I mentioned, the scientists came together, but it originated in the mind of Dr. K. Kasturi Ranganji. He's a former chairman of ISRO, and he played a key role. Even your national education policy, if you have heard about, he played a very important role. And imagine the person who is leading the ISRO mission of Chandrayaan 1. He's the one who's also talking about education policy. And he said, and I quote him, "It is not a question of whether we can afford to go to the moon. It is whether we can afford to ignore it." So this is what, I mean, the statement speaks about itself. May I have a next slide, please? So we talk about Chandrayaan 1, and then we move further. Let's see what happened in 2008. So 22nd October 2008, like this, we were not here, but Chandrayaan 1 was being launched at Satish Dhawan Space Center, Sriharikota, Andhra Pradesh, and this has been the site specified for the launch. There are various reasons. You must read that, why it is near Bay of Bengal and is near equatorial region. You can put satellite in space immediately at that particular place. And over the years, it has been facilitated, and the facilities are all for launches. So this is the reason Sriharikota place and Satish Dhawan Space Center has been chosen. Launch vehicle was the first one, which we mentioned, PSLV. And it carried 11 payloads. I shall come to that. But on 14th November 2008, in fact, 8th November, it reached the lunar orbit. And within 6 days, there was an impact. So it carried orbiter, and it carried the impact probe, and orbiter left the, the impactor, left the orbit and hit the south pole of moon. And the splash which came up, and we could study the sub-solar layer, sub-lunar layer, and the studies were carried out by the instruments which were carried. So the objective was to study the lunar surface and to make a complete map of its chemical characteristics. The probe lasted for 312 days, and this is where I would say that it inspired us to go further. And after that, it was supposed to last for two years, but failure of sensors and inadequate thermal shielding shortened the lifespan of spacecraft, as we mentioned, 312 days. So mission elapsed time was, instead of 2 years, it was 10 months, 6 days, 19 hours, 7 minutes, 49 seconds. And that's how we mentioned the time when we are talking about such missions. So in August 2009, I think it's 29th August, we are not mentioned here. 29th August, Chandrayaan 1 lost contact with the ground station. And while hovering over 100 kilometers above the moon's surface, it actually lost contact. And after a while, ISRO officially declared that the mission was over. The impact road, which I mentioned about, crashed such a way, and I also mentioned the subsurface soil was to be analyzed. And to analyze for the traces of ice, the objective was that. So it carried the Chandrayaan-1 was carrying 11 payloads. And when you say 11 payloads, is about ISRO had 5, NASA also we took foreign payloads also, the instruments they wanted to put up on the spacecraft. We took 2, we are permitted 2 from NASA, and it was miniature synthetic aperture radar, which detected patterns of water ice in the reflection of polar crater. And then also there was M3, you may have heard or please read. It's called Moon Mineralogical Mapper. And this instrument also helped how the lunar surface reflected and absorbed infrared light. So, and this was to confirm the presence of water. So both these instruments were on board to aid search of water. There were 3 equipments from European space agencies and 1 from the Bulgarian Aerospace Agency. So even when I mentioned about the 5 from ISRO, and also the 2 instruments of the European Space Agency had Indian collaboration. And the mission cost was $56 million. What was the outcome? The outcome was that while hovering around 100 kilometers above the moon's surface, Chandrayaan-1 took high resolution images of the moon's topography, mineral mapping. So magnesium, silicon, aluminum was also detected. And what was to be checked was any radioactive element, and also discovering water on the moon, and which was the significant goal of the mission. The major achievement, as I mentioned, was the discovery of the traces of water molecules on the moon in the form of water ice. So when Apollo had brought lunar samples, water was found while experimentation, and it was assumed that is a earth contamination, how there will be, the moon samples are dry, there cannot be water, but water was detected that time, but it was assumed to be contamination. But this Chandrayaan-1 proved that there is some traces, I shouldn't say proved, but yes, the discovery of some traces of water molecules on the moon in the form of water ice was detected. Scientists speculated that frozen water near the moon's south pole. So moon's south pole, which could be used for a variety of purposes. Drinking purpose, it can be for rocket fuel, generation of rocket fuel, it could be oxygen generation, even to grow plants, if you are ambitious also. But if you look at Chandrayaan-1 mission was a huge step forward the future lunar exploration. We made an attempt and we were successful. May we have the video if there is there?
India, a major spacefaring nation, has conducted a detailed exploration of the moon through its Chandrayaan program. The country has sent 2 robotic spacecraft to orbit the moon and to take a repeated look at its surface. Chandrayaan-1 demonstrated India's ability to reach the surface of the moon at a place and time of its choice. And with it, India became the 4th country to reach the surface of the moon in November 2008. Besides, Chandrayaan-1's conclusive discovery of water on the moon in 2009 was praised as a path-breaking discovery.
All right. Chandrayaan-2 stands testament to India's unwavering commitment to space exploration. So once again in the space, with an aim to further unravel the mysteries of moon and expand our understanding of Earth's celestial neighbor. Same launch pad from where Chandrayaan-1 had taken off Sriharikota, Satish Dhawan Center, launched on this month in 2019, 22nd July, by Indian Space Research Organization. Instead of PSLV rocket launching vehicle, the spacecraft made use of advanced geosynchronous satellite launch vehicle Mark III. And it did incorporate improved instruments and new technologies, intended for future planetary mission. Every time when you go for another mission, there is advancement in technology, new instrument, new equipments, and new objectives needs to be achieved. The best part, because this particular, as a woman, I would like to pay respect to two women who spearheaded this project, and chairman is of ISRO, Dr. Sivan, of course, but two women, which is project director Ritu Karidal and mission director Mutya Vanita. I believe they need that round of applause that they reached this level and could be looking as mission directors for the Chandrayaan 2. The lift mass of 3850 kg in Chandrayaan was 1380. This was 3850, more than double, and it landed on September 7, 2019. It entered the lunar orbit, and on that day, we thought that it had three parts. So orbiter, then lander Vikram, and Pragyan as rover. So orbiter was designed to operate for 7 years, 2 to 7 years, and lander, which landed, supposed to land Vikram, and who was named Vikram in the honor of founder Vikram Sarabhaiji, and it had been designed to work for 1 lunar day. And you all know what is 1 lunar day is equivalent to how many Earth days? 1 day, 1 lunar day is equivalent to how many Earth days? 14. All right. So 14 Earth days. So it was planned, it was designed to work like that. And a rover named Pragyan. Pragyan means, in Sanskrit, it means knowledge. So it weighed 27 kgs and it worked with solar energy. So it is a robo vehicle. We will show you, and it has 6 wheels and can travel up to 500 meters slowly. But it was supposed to communicate to the Vikram lander. It cannot communicate to the orbiter. So orbiter orbits, right? Orbiter will detach from the lander, which will land, and lander will drop the rover or detach the rover or let rover walk on the space, on the moon, on the lunar surface. So any reading or any experiment to be done was supposed to be done by the rover, and the rover was supposed to pass on the information to Vikram, and Vikram will submit the information to orbiter. But rover could not convey the information to orbiter. It is designed like that. So its aim when we launched, we went for this mission. The aim again was to explore the surface of moon, to take the sample of soil. So rover was supposed to take the sample of soil and do surface analysis, send data to Vikram, and which will then relay that to the orbiter and then to the Earth. The orbiter sends information to the Earth. So both were, as I mentioned, were supposed to function together, and for 1 lunar daytime, if they had to land successfully, it was only 1 lunar daytime. So 14 days mission it was. So before I go further, I would want a video of, if it's there, Chandrayaan 2. Chandrayaan 2. Can you see orbiter is there still, and the lander has detached. Small height. The speed was very high. Height was, they were 5 inches. More points, more fetching, more wires for cover protection from you. What comes out? Can move 500 meters and take the information, pick up the soil sample, analyze, and convey to the lander. So supposed to happen like that. 15 days, One lunar day, that's 14 Earth days. It will happen. Chandrayaan 1, as I mentioned, it carried 11 payloads. It means it welcomed all the space agencies which could ask India, can you take our equipment too? It welcomed, but this time they said, no, we cannot take a heavy payload, but it still orbiter, which was orbiting, could carry 8 payloads. And while the lander, which landed Vikram, carried 3 and rover just 2. The orbiter orbits, hovers around over 100 kilometers. At a distance of 100 kilometers, it performs, even orbiter continues to perform passive experiments, just like it did in Chandrayaan 1. So the experimentation continues. The mission cost was this time, previous it was $56 million, and it was this time $141 million. And what was achieved? What was achieved in Chandrayaan 2? Everyone talks about how much you did not get marks, how many, where you failed, but where did you pass? In which subjects you fared well? In science and experiments, observation, there is no failure. It's always a learning, is always an inference, and we repeat the experiments. The cost is much, yes, when you talk about the space programs, but that's how it's a huge mission and is unmanned. It has to be controlled from Earth. The challenges are as many. So Vikram lander, soft landing was not achieved as intended, but mission demonstrated India's technological capabilities, including ability to design and launch complex missions to the moon. And it continues to do so. It showcased the country's achievements in space exploration and positioned India as a key player in the global space community. The orbiter, which remained in the lunar orbit, continues to function and gather crucial data about the moon surface, atmosphere, mineral composition, and what is we wanted or targeted, even lunar geology. So understanding lunar geology, and also it helps us for the future mission. So everyone said that Chandrayaan 2 failed. Did it fail? So big round of applause for ISRO scientists. Do we have the graph? All right. Why the South Pole? All right. Why the South Pole? Because South Pole, if you see the moon and look at it only faces one side, faces Earth. Extreme temperatures, minus 180, the coldest part, which is farthest part, and 130 degrees centigrade, which is exposed to sun. Imagine that the farthest part has supposed to be having ice, because there are craters too. So the ice could be trapped into it, and there's a reason this time and last time also, India, our country, wanted to land on the South Pole. Next, please. Why do you think there'll be water on the moon? So please read this. It's assumed that if it is in space, many meteorites, many asteroids, or planetary objects must be crashing on the moon and may leave water molecules on the surface. But due to extreme temperature, imagine the temperature there. Do you think water could survive or could be evaporated? But because of the pressure conditions, the magmatic water, which is trapped in the igneous rocks, could be there. This is what the assumption is. So quite possible that might not get evaporated. So moons, and also the moon's axis is slightly tilted. There are several craters on the poles within permanent shadow of the sun's light. And it may be hidden reservoirs of water. So all unknown, we do not know, but there is a hope. There's a water, many missions. Actually, it become efficient. It will be quite cost efficient missions, because once water is there, many missions could be, or exploration could be planned. Next. Yes, Do you remember this? Did you see that on 7th September 2019? I can't see you all, so I don't know I can't ask you to raise hands. How many of you witnessed this? I witnessed this. Yes, I can see some hands. Can you put the lights on for 1 second? I want to see how many witnessed this. Yes, may I repeat the question? Did you witness this? Oh, 3 only. All right. What is this? It's a stoppage of the heartbeat for the scientist. Yes. For me, when I was watching, I thought internet disconnect ho gaya, better that. If there's a disconnection from the internet, it's better. You think ISRO would happen that? No. But there was a feeling something has gone wrong on the screen. Landing must have happened. And there was a wish. The landing should have happened. May that we have missed it. But it cannot stop. And just 2 kilometers on the surface after reaching all the miles from Earth to lunar, and this dot, when stopped, people were jubilant that's about to reach. And this was just 2 kilometers above the surface, 2 kilometers above the surface of moon. What does it indicate? You planned very well. There was a little miss and just 2 kilometers. So the 5 engines now reduced to 4. The throttle engines which are there and this can be reduced to 4. The velocity could control because the velocity increased high. It landed, it went on rolling. It could not reach the site and it was disappeared and got damaged. So rover never came out. Its lander landed. And if you saw in the picture, did you see the orbiter was scanning? And it could be seen that orbiter scanned lander Vikram on the surface of the moon. And they tried remotely from, of course, it has to be remotely from here to bring into action. There was a hope that Vikram could be made alive. But imagine in life also is a race and quite possible before finishing line. There's a finishing line and just 2 minutes before that. But you're about to reach the finishing line. Nobody should get disheartened. Again, take a next race. You will finish and you will cross the finishing line. Can we go ahead? All right, so this is September 7, 2019, and the entire ISRO community with Honorable Prime Minister of India, Modi ji was also there with scientists, and there was just a second before there was a joy, and a second later, they all were absolutely, there was a silence. I did not know what happened, and this is that scene, and this is that screen which I realized I must show it to you. All right, coming to, yes. Before we come to, and I mentioned about what went wrong, and ability of the software to correct could not be done. But anyway, what went wrong has been corrected. And we are very, very hopeful, and we should convey our best wishes and congratulations from this place of Mumbai to all the scientists. Chandrayaan 3 will be successful. What's the beauty of this? Are you showing the video? Is it? All right.
100 kilograms,
time,
Chandrayaan 3 spacecraft is being sent to the moon with the objective of making yet another focused attempt to slowly land on the lunar surface and to explore it with the help of a rover. Following the spacecraft launched by India's most capable rocket, LVM-3, the Chandrayaan 3 lander carrying a rover within it will be carried into an orbit around the moon by the propulsion module. A little later, the lander will separate from that module and will attempt to make a soft landing in the south polar region of the moon. This region is of intense interest as it has many permanently shadowed craters which could contain water ice and precious minerals. Chandrayaan 3 lander has 4 scientific instruments or payloads, of which one will study the moonquakes, while the other one studies as to how the surface of the moon allows heat to flow through it.
please watch carefully.
The third one will study the plasma environment near the moon's surface. And the fourth instrument will enable scientists to measure the distance between the Earth and Moon very accurately. The two instruments on the rover help us study the composition of the Moon's surface using X-rays and laser, respectively. While the lander and rover will be in direct contact with each other. The propulsion module circling the Moon will observe the light coming from Earth, the only planet which we know which is definitely teeming with life. This observation will help in understanding the nature of distant planets circling stars other than the Sun. As Chandrayaan-3 undergoes important tests and gears up for launch, thousands of ISRO scientists, including those who will launch it, control it, and receive the precious scientific information from it using giant dish antennas, are readying themselves for the challenging tasks ahead. In the past, their dedication and skill have enabled India to earn praise from across the world and made it proud. Let us wish them well in this great endeavor called Chandrayaan-3.
Quick review about Chandrayaan-3. More rigid, well-equipped, well-structured, consists of lander and rover. This time, no orbiter. Did you notice that? Previous Chandrayaan-2, there was orbiter, lander, and rover. And this time, orbiter is already there, exists there. So we are sending lander and rover. Our ISRO chairperson, Somnathji, is considered, we know that, one of the brains behind this mission, Chandrayaan-3, and he said, and he called it as landing and roving mission. So it will be the first mission to land on the Moon's south pole, and I would say successfully. As I mentioned, parts of the South Pole are permanently in shadow, and it is raising possibility of water and ice. So hopefully we are able and we confirm the presence of that. And also the most important is that large craters are also there near the South Pole, and which contains the clues to the composition of early solar system. So this particular mission will give us a complete close-up view of an entirely new region, and also we can see and study Earth from Moon as well. We talked about the launching vehicles. If you remember, PSLV for Chandrayaan-1, GSLV for Chandrayaan-2. This time it is LVM-3, but it is nothing but it is GSLV only. G they are not writing, but it is geosynchronous launching vehicle M3. So it's famously called as Bahubali of rockets, and it is 3-stage rocket. This is the advancement. So every mission we are advancing scientifically and technologically, and is equipped with 2 solid fuel boosters and a liquid fuel core stage. Maybe that they thought the fuel might have gone out of reserve, why hence could be the crash landing last time or whatever happened. So they are not taking any chance. Other part is the propulsion module, which will behave like a communication relay satellite. Will get an information about the rover and the Vikram together. The names have not been changed. Still, the lander is named Vikram and a rover as a Pragyan. So propulsion module will carry the lander and rover. The configuration we have set such a way that spacecraft is in 100-kilometer lunar orbit. So as I mentioned, Vikram as a moon lander, which is equipped with the 4 instruments. The video also said, it records thermal conductivity, sends moon quakes, if there are any, around the landing sites, and also other data. Apart from, I mentioned that mineralogical data, other things will also be part of it. And it consists of 4 engines as compared to the previous lander. It had 5 engines. So, and we are planning this mission also with Vikram lander and rover, Pragyan rover, within less than 14 days as planned, and is equal to 1 lunar day, which we mentioned. And as the equipment works only in solar energy. So it is designed like that. It should reach moon in the moon's orbit and land on 23rd August. So hopefully we should be here if we are around and witness that as well and see the success of Chandrayaan 3. Yeah, more louder for them. I hope they hear that. So what is addition to Chandrayaan 3? What is new? And what is the methodology? This you must hear this. Chandrayaan 3 has more fuel. So prepared with the more fuel, even Vikram lander. All failures have been looked at. In life, you must, we say there's a SWOT analysis. So we should know our strengths, we should know our weaknesses, we should know challenges and opportunities. There are many opportunities when you land on the moon. There are strengths that we have technology and science with us, but we should look at the weaknesses and the failures which we have faced. So what could be the failures? Sensor failure, engine failure, algorithm failure, calculation failure. So this model, whatever may be the failure, it will land at the required speed at different failure scenarios which have been calculated and programmed inside. So this is the statement that whatever be the failure, it will land at the required speed. Vikram lander has additional solar panels on the surfaces to ensure that it keeps generating power no matter how it lands. There should not be short of the power. If same issue of high velocity, assuming what happened before, comes in picture while landing, the system will work by increasing the vertical velocity from 2 meter per second to 3 meter per second and has been tested for the same. So with the velocity increases, the vertical velocity will increase and they will cover up that also. So all these testing have been done. We call this as simulations and simulated tests have been carried out. Spacecraft has been tested for ability to withstand vibrations while flying it over different terrains, so using helicopter. So even that study has been done. So if we talk about Chandrayaan 3, quickly, we have a couple of minutes so we can question. So I told them to alert me at 2:15. So ISRO, and along with ISRO, we all continue to learn from our experiences. They learn from their experiences, but they are motivated to do better in their future for the nation. I request you keep motivating yourself and do better for your future so that you can serve nation. And we learn from the failures, and that is the biggest lesson. And we should be confident enough and also motivate others that they will do better. So India, friends, I will want to close this because I don't want you to miss out the launching. So India is the only country which has successfully completed its maiden interplanetary mission to Mars. Are you aware? Yes. Mangalyaan was launched in 2013 and has completed so many years now, almost 10 years. Proud moment in the history that no other space agency has been able to achieve this feat. And that's the reason we have got world records launching and also many other satellites in single mission. So ISRO stands on the 5th position in the world, and very soon it will grow up in the position. And maybe in the near future, India will be superpower and leading in the space knowledge, science and technology as well. And very soon, India will show prove its dominance in the world, and that too with innovative cost-effective solutions. You know, whatever is the budget of NASA is not even fraction of that for India, and yet we are performing. That's the big thing. So we have cost-effective solutions. Lastly, I want you to read the quote. I would like to quote Dr. G. Madhavan Nair, Chairman ISRO. 20 years from now, when space travel is likely to become mundane, like airline today, we don't want to be buying travel tickets from other countries' space vehicles. We have to access our space. So with this, we have lights in the hall. A quick imagine Chandrayaan 1 take you to the journey to Chandrayaan 2 and Chandrayaan 3 before it is being launched. I think you should feel proud about the effort of the scientists of ISRO, as I kept mentioning again, and see that you reach there. Data science students have already reached ISRO. They have gone there, they visited there, they're inspired, and there's a reason it has culminated into this event. So my congratulations to the department head, Shailaja Rane, all the leaders of members of Data Science Club for having inviting me in my own institution, in my own university to speak. And it's indeed an opportunity. I always love one thing is to speaking out to students and to everyone who wants to listen. Thank you so much. And let's wish once again ISRO all the best, and all the scientists all the best. And we will succeed 100%. Thank you so much. Any question and answer we can, I think Rupas, please test and try. We can do afterwards. I will be around. Please write down the questions and do ask. Yeah, come over, come. Don't waste time.
Wow, what a speech. Can we have a huge round of applause to ma'am? This speech reminds me of one thing that we were discussing with ma'am. Ma'am had quoted, what India will see in this coming decade, the world will see. Can we have a huge round of applause for that statement, ma'am?
That's okay.
Yes, ma'am. Ladies and gentlemen, let us take a moment to express our utmost gratitude to Dr. Hemlata Bagla ma'am for sharing her valuable insights and expertise with us today. We're truly privileged to have had the opportunity to learn from her profound knowledge and experience. Now, as we move forward with this extraordinary event, I kindly request everyone to prepare themselves. Fasten your seatbelt, guys, for the exhilarating launch that awaits us in just few minutes. The culmination of our collective efforts and the spirit of exploration is about to unfold before our eyes.
We are very close to the launch. And the day of launch, wind biasing data is fed during the countdown to the onboard computers to enable most suitable steering of the launch vehicle through atmosphere. Up next, we will watch a curtain raiser video on this
Event
mission.
number 465, request CGSS to confirm supply of GN2 to cryogenic.
Moon. This familiar object in the night sky has inspired the imagination of astronomers and ordinary people alike. From time immemorial, humans have marveled at the beauty of the moon, used it to count time and navigate the high seas. In modern times, moon, the only natural satellite of the Earth, has acquired added importance due to the belief that moon is the key to our understanding of the evolution of the solar system in general and Earth in particular. Besides, moon's precious resources and low gravity have further endeared it to humans. India, a major spacefaring nation, has conducted a detailed exploration of the moon through its Chandrayaan program. The country has sent 2 robotic spacecraft to orbit the moon and to take a repeated look at its surface. Chandrayaan 1 demonstrated India's ability to reach the surface of the moon at a place and time of its choice. And with it, India became the 4th country to reach the surface of the moon in November 2008. Besides, Chandrayaan 1's conclusive discovery of water on the moon in 2009 was praised as a path-breaking discovery. The follow-on mission, Chandrayaan 2, had an orbiter, a lander called Vikram, and a rover named Pragyan. In the past 4 years, the
T25
orbiter
return
has
actuation in
repeatedly
progress.
observed the lunar surface and even today is working satisfactorily. Now, 3,900 kilograms Chandrayaan-3 spacecraft is being sent to the moon with the objective of making yet another focused attempt to slowly land on the lunar surface and to explore it with the help of a rover. Following the spacecraft launched by India's most capable rocket, LVM-3, the Chandrayaan-3 lander carrying a rover within it will be carried into an orbit around the moon by the propulsion module. A little later, the lander will separate from that module and will attempt to make a soft landing in the south polar region of the moon. This region is of intense interest as it has many permanently shadowed craters which could contain water ice and precious minerals. Chandrayaan-3 lander has 4 scientific instruments or payloads, of which one will study the moonquakes, while the other one studies as to how the surface of the moon allows heat to flow through it. The third one will study the plasma environment near the moon's surface. And the fourth instrument will enable scientists to measure the distance between the Earth and Moon very accurately. The two instruments on the rover help us study the composition of the moon's surface using X-rays and laser, respectively. While the lander and rover will be in direct contact with each other, the propulsion module circling the moon will observe the light coming from Earth, the only planet which we know which is definitely teeming with life. This observation will help in understanding the nature of distant planets circling stars other than the Sun. As Chandrayaan-3 undergoes important tests and gears up for launch, thousands of ISRO scientists, including those who will launch it, control it, and receive the precious scientific information from it using giant dish antennas, are readying themselves for the challenging tasks ahead. In the past, their dedication and skill have enabled India to earn praise from across the world and made it proud. Let us wish them well in this great endeavor called Chandrayaan-3.
आपके सामने हैं इसरो के अध्यक्ष श्री एस सोमनाथ। अभी अभी आपने देखा एक संक्षिप्त वीडियो जिसमें एनिमेशन की मदद से इस पूरे मिशन की यात्रा को बताया गया है, इस मिशन के ऑब्जेक्टिव को समझाया गया।
Which tank level correction completed?
Chandrayaan 3 has 2 predecessors with destination moon as their mission objective. Chandrayaan 1, launched by PSLV C11 in October 2008, included lunar orbiter and impactor. During the mission life of around 10 months, Chandrayaan 1 had mapped the minerals on lunar surface, acquired 70,000 images to help create 3D atlas of moon, and what's more, found water on moon's polar regions. Chandrayaan 2, launched by LVM-3M1 on 22nd of July 2019, consisted of lunar orbiter, lander named Vikram, and rover named Pragyan. The orbiter is still providing insightful scientific information through its payloads like spectrometers, synthetic aperture radar, and cameras.
चंद्रयान 3 की चंद्रमा की सतह में उतरने के इस मिशन को कुल 10 चरणों में पूरा किया जाएगा। संक्षेप में यह इस प्रकार है। सर्वप्रथम चंद्रयान 3 को LBM-3 प्रमोचक रॉकेट द्वारा पृथ्वी की एलिप्टिकल टारगेट ऑर्बिट, जो कि 170 बाई 36,500 किलोमीटर की ऑर्बिट है, उसमें प्रमोचित किया जाएगा। वहां से चंद्रयान में मैन्यूवर कर पृथ्वी की गुरुत्वाकर्षण की सहायता से चंद्रयान की गति को वृद्धि की जाएगी। फिर चंद्रयान पृथ्वी की कक्षा से निकलकर चंद्रमा की कक्षा में जाएगा। चंद्रमा की कक्षा में जाते ही उसमें फिर से मैन्यूवर कर चंद्रमा की 100 किलोमीटर की वृत्ताकार कक्षा में स्थापित किया जाएगा।
S200 prime chain actuation in progress.
फिर सही समय आने पर लैंडर मॉड्यूल को प्रोपल्शन मॉड्यूल से पृथक कर दिया जाएगा। यह आप अपनी स्क्रीन पर देख पा रहे हैं, यह प्रोपल्शन मॉड्यूल। प्रोपल्शन मॉड्यूल का मुख्य उद्देश्य है लैंडर तथा रोवर को पृथ्वी की कक्षा से चंद्रमा की कक्षा में, जो कि 100 किलोमीटर की वृत्ताकार कक्षा होगी, उसमें उचित अभिवृत्ति में लैंडर मॉड्यूल को अपने से पृथक कर चंद्रमा की सतह पर भेजना है। ऐसा करने के लिए इसमें एमएमएच और मॉन का प्रयोग कर 440 न्यूटन के थ्रस्टर्स वाले इंजन लगे हुए हैं।
S200 prime chain actuation completed.
इसमें आवश्यक संचार सुविधाएं भी उपलब्ध हैं।
Speaking about the major milestones in the journey of Chandrayaan 3 to the moon, the spacecraft consists of propulsion module, lander, and rover. Lander is planned to touch down at south pole of moon. The major 10 phases of the mission are: the first phase, called the Earth-centric phase, comprises of pre-launch, launch, ascent, and earthbound maneuver. While the second phase is the lunar transfer phase, as the name suggests, the Chandrayaan spacecraft moves closer to the moon. Next 8 phases are in the moon orbit. The third being the lunar orbit insertion, followed by the moon-bound maneuvers phase,
Vehicle on
which mark the
power.
fourth phase. And next is, it is now that the propulsion module separates from the lunar module when 100 by 100 circular orbit of the moon is achieved. The Chandrayaan 3 in its sixth phase carries out D-boost
External power
from
withdrawn.
100 kilometers to 100 by 30 kilometers orbit, followed by the pre-landing phase as seventh phase, and then the most awaited
Flight
landing
position
phase
started.
takes place.
Flight coefficient loading complete.
आपके सामने है मिशन नियंत्रण कक्ष का दृश्य। सभी सेंटर डायरेक्टर्स अपने स्क्रीन पर देख रहे हैं कि ऑटोमेटिक लॉन्च सीक्वेंस किस तरह पूरा हो रहा है। दर्शक दीर्घा भी इस इंतजार पे। प्रमोशन से हम 5 मिनट की दूरी पर हैं।
-5 minutes.
Most of you might recall the Chandrayaan 2 mission
MC confirms radar
and the
data.
intense moments when all the enthusiastic Indians were waiting for the touchdown of the lander on the surface of moon. The launch view gallery with the overwhelming crowd of visitors.
पूरे दर्शक दीर्घा यहाँ बहुत उत्साहित। मौसम में थोड़ी परेशानी हो सकती है, लेकिन सब अपनी सुविधाओं के साथ में यहाँ उपस्थित हुए हैं।
We are close to 4 minutes from the scheduled launch time.
-4 minutes.
Gaining from the heritage of Chandrayaan 2, the Chandrayaan 3 is upgraded in several aspects for the enhanced robustness
Fire
through
and
extensive
battery.
ground tests and simulation.
Onboard computer in flight mode.
ऑटोमेटिक लॉन्च सीक्वेंस जारी है। इस दौरान सभी संचार तंत्रों की स्वास्थ्य जांच, बैटरी आवेशन पूर्ण किया जा चुका है। कुछ अंतिम गतिविधियां जैसे ऑनबोर्ड कंप्यूटर पर रियल टाइम प्रोग्राम लोड करना, पायरो लाइन को आर्म मोड में लाना, गैस टैंक्स का अंतिम आवेशन, और यह सभी घटनाएं संतोषजनक तरीके से पूर्ण की जा रही हैं।
-3 minutes.
अब हम उड़ान से 3 मिनट की दूरी पर हैं। प्रमोशन तथा इस प्रमोशन की घटनाक्रम को पहले ही बताया जा चुका है। सर्वप्रथम दोनों S200 स्ट्रैप-ऑन बूस्टर प्रज्वलित किए जाएंगे T0 पर।
Pre-flight pressurization of the hydrogen tank commenced.
S200 के प्रज्वलन के 108 सेकंड के पश्चात L110 जो कि
-2 minutes,
तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू कर दिया जाएगा। L110 के प्रज्वलन के पश्चात करीब 137 सेकंड पर S200 बूस्टर्स को यान से पृथक कर दिया जाएगा।
We are close to 1.5 minutes from the scheduled launch time.
सभी दर्शकों को ज्ञात है यह एक ऐतिहासिक मिशन होने वाला है। पूरे
-5 seconds, -50 seconds,
All sequences armed. Stage ready. TB ready.
-45 seconds, -40 seconds,
L110 VHPP open. MOV 79 open.
-33 seconds, -30 seconds,
Real-time programs activated.
-25 seconds,
L110 VSPP open.
-20 seconds, -15, 10, 9, 8, 7, 6, 5, 4, 3, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
Here we have a majestic liftoff of
Auto tracking.
LVM-3 M4 rocket carrying India's prestigious Chandrayaan 3 spacecraft.
P2 tracking.
प्रज्वलन और सफलतापूर्ण उत्थापन LVM-3 M4 रॉकेट का। यह भीमकाय रॉकेट आसमान को चीरते हुए अपनी भयानक दहाड़ से चारों ओर कंपन उत्पन्न कर रहा है, जिसे हम महसूस कर सकते हैं। और यही दहाड़ है जो वैज्ञानिकों को रोमांचित करती है। LVM-3 के उत्थापन के साथ ही हमारे अंतरिक्ष यान चंद्रयान 3 की चंद्रमा की यात्रा प्रारंभ हो चुकी है।
As the rocket is soaring through the clear skies, every second moving every Indian witnessing the launch live is content with the feeling of watching history. Live is content with the feeling of watching history in the making.
चंद्रमा की सतह पर अपना छाप छोड़ने के लिए चंद्रयान 3 अपने मिशन को पूरा करने निकल चुका है। वर्तमान में दोनों S200 स्टेप-ऑन बूस्टर सामान निष्पादन करते हुए अपनी निर्दिष्ट कक्षा की ओर बढ़ रहे हैं।
S200 motors thrusting simultaneously, generating a peak thrust of close to 6,000 kilonewtons in vacuum. They are made of HPP-based solid propellant, 204.5 tons in each strap-on, close to 2 tons of propellant being burnt each second.
S200 स्टेप-ऑन बूस्टर्स का कुल प्रज्वलन काल 126 सेकंड का है और अभी अभी घोषणा की गई L110 स्टेज का भी प्रज्वलन शुरू हो चुका है।
Apart from the strap-ons, the core stage has also commenced its operation. This stage, based on combination
200 stages are separated.
of hypergolic earth storable liquid
Group guidance
propellants
initiated.
UH25 and N2O4. Now the S200s have been separated.
घटनाक्रम के अनुसार यह यान इस यान से S200 स्ट्रैप-ऑन बूस्टर्स को सफलतापूर्वक पृथक कर दिया गया है। यह काम सेपरेशन मोटर्स की मदद से किया जाता है। इसके बाद L110 तरल नोदक पर आधारित और विकास इंजन के साथ यह चरण सामान्य निष्पादन करता हुआ अपनी उद्दिष्ट कक्षा की ओर बढ़ रहा है। अब यान
3 minutes.
क्लोज लूप गाइडेंस के अंतर्गत है।
L110 stage performance normal.
The trajectory of launch vehicle is closely following the prediction.
Payload pairing separated.
यहाँ पेलोड पेयरिंग को पृथक कर दिया गया है यान से, क्योंकि यान अब 114.8 किलोमीटर की ऊंचाई प्राप्त कर चुका है। इस चरण का कुल प्रज्वलन काल 200 सेकेंड होता है और इस दौरान यह करीब 1600 किलो न्यूटन का प्रणुद उत्पन्न करता है।
We are 220 seconds past the launch time. Current altitude is 135 kilometers. In the 200 seconds of its operation, the L110 stage carries the rocket up to 175.5 kilometers altitude and imparts a relative velocity of 4.18 kilometers per second. That is 250 kilometers every minute.
L110 stage performance normal.
LVM-3 M4 रॉकेट का द्वितीय चरण पूर्णतः सामान्य निष्पादन करते हुए इस चरण में कुल 113 टन के तरल नोदक भरे जाते हैं। N2O4 तथा UH25 अर्थ स्टोरेबल प्रोपेलेंट को ईंधन के रूप में प्रयोग किया जाता है इस चरण में।
payload also is improved by mission strategies as well as vehicle engineering approaches. We are in the process of increasing the launch frequency of this vehicle, considering the national requirements as well as satellite demands. Here, so many improvements we have incorporated in this vehicle. For example, the S200 nozzle, they are processed exactly as per the human rating standards, enabling us to have 100% NDT, and the inherent pocket erosion characteristics are removed. The L100 stage Vikas engine, mostly it is 100% qualified to be the human rated engine with indigenously developed LET throats, and the pocket, backward gas entry also is eliminated, and it is a perfect system. Yes. And the CE20 stage also is perfectly actually.
So we will
Yeah.
describe all those details later
Sir.
because of shortage of
Yes,
time.
sir. I take this opportunity to thank all the mission executives because mission executives for all the supports all along the launch campaign process as well as the launch. Once the launch manifest is released and mission executives are identified, really this is a penance of so many across the ISRO centers, our launch vehicle centers, VSSC, LPSC, IPRC, IASU, SDSC, SHAR, URSC, and SAC, along with all our industrial partners, major players to the small scale industries who supply us with all the deliverables in time, quality products, the suppliers of chemicals, propellant ingredients, suppliers of avionics systems, and our own GOCO facility operators. Actually, the industrial manpower is really our ISRO's virtual manpower. Everybody's efforts went into this, and called the also the prayers and best wishes of all our seniors, retired executives, everyone's prayers, and our own family members. I take this opportunity to pray God Almighty for all the blessings in the form of this success, which was the penance by the ISRO family for last 73 days. And my prayerful pranams for the successful continuous operations of the Chandrayaan spacecraft, for its safe and soft landing on lunar surface and further experiments. Thank you. Jai Hind.
Respected Chairman ISRO, Center Directors, dignitaries, and my team Chandrayaan 3. Very happy to note that our Chandrayaan 3 has been injected into an intended orbit with very close orbital parameters. Congratulations and thanks to LVM3 team. And all our spacecraft health parameters are normal, including the power generations in both propulsion module and lander module. Our journey to moon has begun now for the most awaited soft landing. We'll be closely monitoring and controlling the spacecraft from ISTRAC Bangalore. Many critical events are lined up, starting from earthbound maneuvers, insertion into the lunar orbit, and separation of lander, and set of deboost maneuvers, and finally the power descent phase for a soft landing. I take this opportunity to thank Chairman ISRO, Director URSC, and all the center directors for entrusting me this opportunity, who are behind, who have been the motivational and guidance force behind this mission. My special thanks to Chandrayaan 3 project executives, Associate Project Director Kalpana, Deputy Project Directors, Project Managers across the ISRO centers who have provided an excellent support in building the spacecraft. My special thanks to the expert committees for their constant guidance throughout the various stages of the project. I also thank the various work centers and industries who have contributed directly and indirectly to this mission. My special thanks to URSC council members, group directors, deputy directors across the ISRO centers. And looking forward for the soft landing with all your wishes and blessings from the God. Thank you.
We have our Honorable Minister for Space, Minister of State for Space, Dr. Jitendra Singh Ji, amongst us during this historic occasion of success of launching of LVM3. So we would like to hear a few words from him. Over to you, sir.
It is indeed a moment of glory for India and a moment of destiny for all of us over here at Sriharikota who are a part of the history in making. Thank you, Team ISRO, for making India proud. And thank you, Honorable PM Narendra Modi ji, for having made this possible by unlocking the gates of Sriharikota and enabling the India's space sector. You would recall, Honorable Prime Minister had very recently said, sky is not the limit. And living by his words, I think the Chandrayaan today has gone beyond the limits of sky to discover the unexplored horizons of the universe beyond. Ladies and gentlemen, this day today, the 14th of July, 2023, is also a day of vindication. Vindication of the dream that Vikram Sarabhai saw 6 decades ago. He might have been short of resources, but never short of confidence. And when we see those pictures of a launcher vehicle being carried on the carriage of a bicycle, without any remorse, without any slightest embarrassment, that is because Vikram and his team had faith in themselves, faith in India's potential, faith in India's acumen. And today, here, we are vindicating and we are reiterating India's indigenous capabilities, living up to the ideal of Atmanirbhar Bharat. And before I conclude, ladies and gentlemen, as Mother India enters into the next 25 years of this Amrit Kal, she pledges to play a leading global role in the emerging world scenario of 21st century. Thank you and congratulations once again.